Welcome to our lesson on physical properties and changes. This is 5.2 in your textbook. At the end of this lesson, if you feel like you want to learn a little bit more information, the textbook is a great place to go. In today's lesson, we will be looking at two topics, the first of which is physical properties, and the second of which is physical changes. So let's look at physical properties first. So a physical property is essentially describing a substance as is. So if you're looking at a pencil case, you can describe that pencil case without changing anything about it. And that's essentially what a physical property is. It is a characteristic of a substance that can be determined without changing the composition of that particular substance. So you're not doing anything to that pencil case. It's as is. You can describe the color, you can describe the length, or other physical properties about it as well. The only thing you are doing to describe a physical property is observing it using your five senses and maybe some measuring instruments as well. There are two types of physical properties, the first of which is qualitative, and when you see this word, I want you to think of the word quality. So if you're thinking about a quality of something, you're using words to describe it. So a qualitative physical property would be something like color or texture. The second type of physical property is quantitative. And the word that should come to mind when you look at that word quantitative is quantity. That is talking about a measurement. So examples of quantitative properties would be things like mass or length. We'll look at a few other examples as well. So let's take a look at qualitative physical properties first. Like I said, a qualitative physical property is a property of a substance that is not measured and does not have a numerical value. So you are simply using words to describe the substance. If you look at that pencil case and you see that it's red, you're using words to describe it. So that would be a qualitative physical property. Now, other than color, there are a few other physical properties that you can describe without actually having to measure. So those would be other qualitative properties. Let's look at a few examples. The first one is luster. So the luster of a substance simply describes if it is shiny, like this toaster, or if it's dull, like a wooden spoon. Again, things that you can just observe by looking at it. Another thing that you can identify as a qualitative physical property is optical clarity. So optical clarity is a way to distinguish how much light the particular substance is allowing to travel through. There are three different categories that you've probably heard of before. The first of which is transparent, translucent is another, and opaque. So transparent means that you can see right through it. So all of the light is going through that substance. Translucent means that you can kind of see through it, but not very clearly. And opaque means you can't see through it at all. So here's a visual that will help you sort of see this. So at the very right is transparent. You can see right through that glass. All of the light is passing through it. In the second little box or window, you can see some of the stuff, but you can't see all of it. So some of the light is passing through, not all of it. And lastly, opaque, no light is being able to pass through that substance. Looking at our next qualitative physical property, we're looking at brittleness. If you were to try and break a substance, there are two options that can happen, right? If you were to try and snap a substance in half, one, it can break. So if it breaks, we would describe it as brittle. The other option is that it bends, and if it bends, we would say that it's flexible. Now, the next physical property is viscosity. And viscosity applies to liquids that can flow or pour easily or not easily. So let's take a look at an example of water and syrup. Now, thinking about those two substances, water is looser, right? So if you were to try and pour water, it would pour pretty easily. And we would describe water to have a low viscosity. On the other end, we've got things like syrup, maybe even ketchup, that's a little bit harder to pour. So it's a little bit thicker. We would describe it as a high viscosity. Hardness is another qualitative physical property. The official definition of it is that it's the ability to scratch or be scratched by another substance. So on the hard end, you've got something like a diamond, and there are several soft things around us as well. Now, malleability refers to the ability of a substance to be hammered into thin sheets or molded. So the example that I've shown here is of gold. So gold is in this rock, and then if you hammer it, it can become thin and thin and thin, and that's why gold is used for jewelry, because it can be easily molded. So it's a very malleable metal. Moving on, ductility is also a property that is very important for metals. It's the ability of a substance to be drawn or pulled into finer strands. So here the example that I've used is copper. And copper, if you were to pull it into thinner strands, you'll be able to see something like a wire. And that's why copper is used for or as the conductors in a lot of the wires that we have, because it's very, very ductile. Going back to electricity, our last physical property that is qualitative would be electrical conductivity. So we've got two substances here, so these would be ceramics, and we've got metals here. So ceramics are substances that do not allow for electricity to pass through it, and metals are things that do. So we would just describe that to either be conductive or not conductive. Now those were our qualitative physical properties. Let's take a look at our next category of physical properties, which are quantitative. Now, like I mentioned earlier, quantitative properties are properties of a substance that can be measured and has a numeric value. So if you're using numbers to describe it, then it's got to be quantitative. So let's take a look at a few examples. The first one being length. So length, it's a numerical measurement that describes the distance of an object from one end to another. So I've got this eraser here, and if I measure it, it says 5 centimeters. 5 is my number. It's a quantitative physical property. Mass is a numerical measurement of the amount of matter in an object. So you can measure mass using weigh scales. They look something like this. You take your substance, you put it on top of it, you've got the number, the reading that shows up, and that is going to be your measurement or your numerical value. Now the next one's a little bit different. It is boiling point. So boiling point, if you think of the word boiling, you're referring to the process of a liquid becoming a gas. And a boiling point refers to the temperature at which a substance changes from a liquid to a gas. So if you've got a liquid like water and you heat it up, as soon as you heat it up to a very specific temperature, a lot of that liquid is going to turn into gas. That temperature is its boiling point. So the numeric value that we're referring to in a boiling point is the temperature. So whatever degrees, that would be our numeric value. Similarly, we've got melting point. So the melting point is the temperature at which a substance changes from a solid to a liquid. Just like the previous example, in a melting point, the numeric value that we're looking at is the temperature again. So that was it for our physical properties section of the lesson. Very quickly, we're going to be talking about physical changes. Now, physical properties were just describing a substance as is. Physical changes are referring to changes that can occur to a substance without actually creating new substances. Now, that might be a little bit confusing, but I think after you see the examples, it might be pretty easy for you to understand. So, for example, if you fold a piece of paper into an airplane, now what you're doing there is that you're changing the size or the shape of that particular piece of paper, but that piece of paper is still paper, which means that you're not actually changing or making a new substance. Melting ice is another example. So ice, as is H2O. If you were to melt it or let it melt, it is still melting into water, which still happens to be H2O. So there's a change of state, but it's still H2O, which means no new substances are formed. And lastly, mixing sugar into coffee or any sort of dissolving. So if you were to mix salt into water, you're not actually creating a new substance, because as soon as you take that salt water and heat it up, a lot of that water will evaporate and you'll have salt left over. So any form of dissolving is all a physical change. So in this lesson, I taught you about physical properties, both qualitative and quantitative, as well as physical changes as well. Again, this is 5.2 in your textbook, and for homework, I want you to do questions 2 and questions 4 as well.